Episode 247, What is the Carbon Cycle? This is the Change Underground for the week ending 1st of March 2021. Hi, I'm your host, John Moore. Decarbonise the air, recarbonise the soil. From the NASA Earth Observatory site, quote, through a series of chemical reactions and tectonic activity, carbon takes between 100 and 200 million years to move between rock, soil, ocean and the atmosphere in the slow carbon cycle, end quote. This sort of thing has been going on since the Earth started to form and cool down. And this is not the cycle we're messing with as humans, but it is worth knowing that it happens and that it acts as a thermostat for the planet. Sort of base level of temperature is a good way of thinking about it. Remember, this is the slow carbon cycle. In this cycle, rain forms compounds with CO2 in the atmosphere and falls to Earth as a weak acid. This dissolves rocks, slowly, which flow into the ocean, little bits of acidic rock and dust and whatnot, where it forms calcium carbonate in the form of shells on sea shellfish, and plankton and phytoplankton and so on. These die eventually, falling to the bottom of the oceans, and are driven through plate tectonics into the liquid part of the Earth, where the carbon wanders around until it is ejected again as CO2 through volcanoes, and the cycle recommences. Now it appears this cycle takes between 100 and 200 million years. And this, as I said, was called the slow carbon cycle. The other cycle, and not surprisingly, is the fast carbon cycle, and it is considerably faster, about that of a human lifetime. It is one we are probably pretty much familiar with. Carbon is on this planet the element of life. Carbon bonds are pretty much everywhere in living things, and the more complex of these store much energy in their bonds, releasing that energy when the bonds are broken. There are therefore great food resources for living things that are themselves comprised of these complex molecules. DNA itself is built around two chains of complex carbon. Phytoplankton at sea and plants on land and at sea represent the major components of the fast cycle. They are where the carbon is lodged, in other words. The key activity in kicking off the fast carbon cycle is our old friend photosynthesis. During this process, carbon dioxide and water combine with energy, sunlight in this case, to create sugar, which is CH2O and O2. In its simplest terms, the carbon moves from the carbon dioxide and is joined to the water. Now these sugars are used to build all the other things in the living world. We are learning how the flow of these sugars and other molecules are mediated by the soil biota, but let's stick with the carbon for the moment. So as with the slow cycle, the fast starts with CO2 and ends with CO2. In the fast cycle, there are but four ways that the carbon held in the sugars, CH2O, can be released to reform as CO2. 1. Plants use the sugar for their own metabolic needs. 2. Animals eat the plants, phytoplanktons and so on, for their needs. 3. Plants are consumed by fungi and bacteria at the end of their life cycle. And 4, the big one, fire. Now a quick look at these would point to some implications for our current warming predicament, points 3 and 4, at the end of the life cycle and fire. But we'll come back to those a little bit later. So the fast cycle varies over the years. In deciduous forests, large amounts of carbon are released with leaf drop, and little is taken up as trees remain dormant over winter. This is counterbalanced by massive growth spurts in spring, so it's an equalising system. And equally, the southern hemisphere is growing with the northern hemisphere is going dormant, and vice versa. Somewhere between 1,000 million and 100,000 million tonnes of carbon are cycled through the fast cycle. As the slow and the fast cycles interact over time, we experience periods of glaciation, ice ages, and periods of interglaciation, not ice ages. So from about 10 to 12,000 years ago, the planet came out of a glacial period, the Pleistocene, and entered the Holocene and into glacial period, all very normal. Now slowly, but increasingly, up to about 1950, humans added more CO2 to the atmosphere each year, until in 1950 we're adding about 2 million tonnes per annum. Since then, that figure has risen to about 8,000 million tonnes. At the same time, we've been clearing more forests in Australia, the Amazon, tropical Asia and Africa and so on, to replace them with pastures and cropping, or worse yet, cities. And so the difference in the total biomass alone should raise questions like, where did all that carbon go, and does it really matter? Second question first, yes it does matter. And first question second, into the atmosphere and oceans. Now back to points 3 and 4, the end of life and fires. The figures aren't fully calculated yet, but the biomass destroyed by the wildfires in the 2019-2020 Australia events has not yet been fully replaced. That is, has not yet drawn down the CO2 that was released. We can see from simple activities like land clearing, or biomass volume reduction in other words, and wildfires, humans can and have disrupted the fast cycle. And now if we toss in, as we must, the volume of CO2 released through the burning of coal, oil and natural gas, which was in fact stationary carbon, the predicament we find ourselves in becomes more obvious. Given that this extra CO2 makes the planet a touch warmer, and then a bit more warmer, and then even more so, and that wildfires increase with increasing warmth, and they release even more CO2 to bump the temperatures even higher, it becomes obvious we are feeding a constantly growing beast. Think wildfires in Siberia instead of permafrost, and the problem is clear. So what's to be done? Now this is where I fall into a deep depression some days. I'm predominantly an optimist, but there are days when I feel helpless in the face of the natural forces arrayed before us. Toss in the brain-dead political situation we have here in Australia and the US and in Brazil, and well, pick any nation you want, and it's a wonder anyone gets out of bed. But we do. We garden, we grow, we build organic matter. We probably don't look too closely at the numbers, for in that direction lies despair. We know what to do. We'd have to recarbonise the soil. That'd be a huge start, and it's easily done. We could knock it over in about 4 or 5 years, according to Charlie Massey, that I mentioned in a previous podcast that I corresponded with him. And it's just a matter of getting soil carbon up by 2% across a third of the agricultural land in the world. A little bit of rotational grazing, a bit of no-till, and Bob's your uncle. It's fixed, however, the fear of change. So we garden, we do what we can, and we know the answer's there, and we keep promoting it. Now, more importantly for me, on a personal level, so I come back to the last 4 lines of a poem by a Kerry poet, Brendan Keneally, entitled Begin. And I will quote those last 4 lines now. Though we live in a world that dreams of ending, that always seems about to give in, something that will not acknowledge conclusion insists that we forever begin. These words give me hope. They haunt me and comfort me. And given the data, a little bit of poetry might just be what we need right now. Thank you all for listening. I'll be back next week.